Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad Adam bin Wan Ahmad Nazri. I am from Mathematics 1. Today I will present to you a real-life application of linear programming. After this presentation, you can apply a linear programming to solve a real-world production problem by identifying the optimal combination of products that maximize profit while satisfying all operational constraints. Do you know what is linear programming? Linear programming is a mathematical method used to determine the best possible outcome in each model subject to a set of linear constraints. Opening intro. I am CEO of juice manufacturing company. I oversee the daily production of two main products, orange juice and apple juice. The price of orange juice that we are selling is 4 ringgit per bottle and apple juice is 3 ringgit per bottle. Problem statement. Fruit supply. The company only can hold maximum of 20 kilograms of fruit per day. We need 0.5 kilograms of orange to create one bottle of orange juice, and we need 0.4 kilograms of apple to create one bottle of apple juice. The company operates under a minimum of 30-hour machine per day. Producing one orange juice only takes 1 hour, but apple juice takes 2 hours. To meet a market demand, at least 5 bottles of each juice must be produced daily. The production budget, maximum 70 ringgit per day. The cost to create one bottle of orange juice is 2 ringgit, while apple juice is 1.5 ringgit. Here are the products that we created with our own brand called One Juice. We have two flavors which are orange and apple juice. Inequality. Let X represent number of orange juice bottles produced per day. Y represent the number of apple juice bottles produced per day. The first inequality is from fruit constraint. 0.5x plus 0.4y is less or equal to 20. The total number must not exceed 20 kilograms. Second inequality is from machine hour. X plus 2y is more or equal to 30. The total number of machine hours is at least 30 hours. Next inequality is budget constraint. 2x plus 1.5y is less or equal to 70. The total number of budget must not exceed 70 ringgit. Lastly, inequality from minimum demand. X is more or equal to 5 and y is more or equal to 5. The total bottle of each type of juice must be at least 5 daily. Objective function. We need to maximize the company daily profit. We use Z equal to 4x plus 3y, where 4 ringgit profit per bottle of orange juice and 3 ringgit profit per bottle of apple juice. Next, we need to make a table. Find point for each inequality by converting them into equation. First is fruit constraint. We can estimate any logical value in one variable to find the value of y. For example, x equal to 0 or 20 or 40. If x equal to 0, we need to put 0 in fruit constraint equation to find the value of y. The value of y that we get is 50. From putting any logical value in inequality, we can finally make a table. Table can make the process of making graph easier. First graph is minimum demand. X equal to 5 represented by purple line and y equal to 5 represented by black line. Second graph is fruit constraint. This inequality is represented by green line. The next graph is machine hour. This inequality is represented by blue line. Lastly, the budget constraint. This inequality is represented by red line. This graph is the combination of 5 lines to find the same shade area. The overlapping shade area is your feasible region. The feasible region represents all the possible combinations of orange juice bottle and apple juice bottle that satisfy all the constraints and are non-negative because you cannot produce negative bottle and respect resource limit and market requirement. To solving objective function, we need to determine the vertices of the feasible region. The key vertices resulting from the intersection of the constraint line are listed as A, B, C, and D. A represented by the color of yellow, B color of green, C color of purple, and D color of red. In this slide, we are evaluating the objective function, which is z equal to 4x plus 3y. At each vertex point that we found from the graph earlier, we substitute the coordinate of each point into the equation to find the value of z. For example, at point A, for the value of x is 5 and for the value of y is 12.5, we are putting the value of x and y in z equation and we get the value of 57.5. Then at point B, we get 95. For point C, we get 140. And at point D, we get 140 also. So the maximum value of Z is 140, which occur at both point C and D. The maximum value of Z is 140. Z get maximum value at point C and D. We must choose point D because it cannot be 31.25 bottle, which is impossible in real life. This means that 5 orange and 40 juice provide a maximum profit 140 under all constraints. For the conclusion that we get from this presentation, I would like to say that linear programming can be applied effectively in real-world business operations. That's all for me. Thank you for listening till the end. Bye.